So we're here in Praia da Vitória in the Azore Islands. That's on a latitude that's about the same as Washington, D.C. The other day we flew all the way from Ascension Island, which is about 500 miles south of the equator, up here to Praia da Vitória. Now, when we did that, we crossed from the southern hemisphere into the northern hemisphere. And in fact, we crossed from the southern climate into the northern climate.
So the flight was very interesting because on the southern hemisphere we flew through a lot of biomass burning plumes which were coming out of Africa, and with our instrument we can measure the dust particles and the biomass burning particles, and then we crossed the equator, and then we flew in this big huge Saharan dust plume coming out of Africa, traveling across the Atlantic Ocean. Mineral dust is about half of the globally emitted aerosol mass per year, and we got the chance to measure all those dust particles, and this will allow us to understand the interaction of the dust particle with the climate. Yeah, I think it's quite exciting to have this data and look at this.
So for the US it's really important because of course all hurricanes start just around Africa in the Atlantic Ocean. They move across the Atlantic. So the dry air and the dust getting wrapped into these hurricanes, they impact hurricanes. And so your measurements are really, really important for understanding this critical science topic for people in the US.
Yesterday we flew from Lajes on the island of Terceira, which is the easternmost island of the Azores, and we flew up over the Greenland ice sheet as far north as we could, and did a profile over a measurement site called Eureka, which is about 85 degrees north. We profiled down and then back into Kangerlussuaq in Greenland. We're on the western edge, about midway down the island, and behind me is the Russell Glacier, which is fed by the Greenland ice sheet, which is a huge source of water to the oceans when this melts. If glaciers are over water, they generally don't have any effect on sea level rise. But a glacier like this that's on the land will have a huge effect on sea level rise. It's been estimated that 80,000 gallons a day comes out of these glaciers. On yesterday's flight, we saw really high concentrations of CO and a lot of biomass burning from all the fires in Siberia. Eventually that biomass burning emissions, like black carbon, they'll be deposited onto the Greenland ice sheet. And here you can see a lot of the black debris that forms from that, which actually makes it start to thaw out a lot quicker because of the dark colour that absorbs extra heat. We're here at the end of the Atom 1 deployment. For our last two flights we flew from Kangerlussuaq in Greenland down to Minneapolis.
And then we flew from Minneapolis back to Palmdale.
So on the flight from Kangerlussuaq we actually saw quite a lot of methane as we flew in over the Hudson Bay lowlands, and then we also saw a lot of methane as we arrived in to do a low approach over Park Falls, Wisconsin. The Hudson Bay lowlands are the largest source of natural methane on the North American continent, so I shouldn't have been too surprised. And Wisconsin has quite a lot of agriculture, and there's a lot of methane that comes from agricultural sources.
So in the last flight we found a lot of biomass burning aerosol again. We have seen it during the whole campaign. So biomass burning is a big source for aerosols and gases, and with the climate warming up there is predictions showing that number of fires might go up.
So this is the tie-up at the end of Atom. As you can see, we actually have a completely empty aircraft. All of the bigwigs and senior scientists have gone home, so it's just the instrument people who are still here, but we've managed to pull everything off in, I think, record time, 2 days. It took us 2 weeks or more?
I think it took us 4 weeks to get everything in, and it's really hard to believe that it took us less than 2 days to get everything out.
So we will see you all again in December for the next startup of Atom 2, which will do the same flights around the world, and hopefully we'll get very different conditions for that.